Okay? So, first thing we're going to do is we're going to learn how to read a chemical formula, Nicole, properly. We're going to learn how to name it. Thankfully, the naming isn't that tricky. It's the rest that gets trickier. Okay? So the first heading is naming compounds. Well, an atom is the smallest part of an element. So you can have a bunch of gold atoms that make up the element gold. It's the smallest part of an element. And atoms combine to form molecules. And a molecule is the smallest part of a compound. Okay? All compounds have a name. So, hopefully most of that was review. So, all compounds have a name and a formula. The name is generally composed of the names of the elements in the compound. Okay, with some changes and exceptions. Nathan, as usual, everything that I'm teaching you is technically wrong. It's going to be right for the simplest cases. Well, you saw in the video the example of a molecule that had 2 molecules and billions of atoms. So we're not going to get anywhere near that high tech, Tristan. The formula uses the symbols from the periodic table. And here's the key idea. It tells how many atoms of each type there are in one molecule. The formula tells you lots of information. I like the formula better, Hudson, because it's less writing and has more information. But the name is how we have to read the formula. Okay? It says, do activity 3-2A on page 84. What 2 rules did you discover? We're actually going to do that together right now. I'm going to pause the video. But what 2 rules did you discover? Rule 1, metal first. Rule 2, non-metal changes to "-ide". Why? Because I'm not in charge. It's just the way it's done. Somebody wanted me to go back, so this is what we had going back. Or if you miss a blank, I can always bring it back up at the end of class too. Okay? I'll scroll back down again in a second too. But maybe you can remember it was metals first, and it was non-metal changes to "-ide". Those were the 2 rules. Okay? Again, if you miss a slide, I'll bring it back. Okay? By the way, I'd rather have you stick with me and not fall behind and miss the current thing because you're trying to fill in a blank from 5 minutes ago. I'll bring it back up. And I know you're like, I want to fill everything in. We'll get it. Naming rules. So here's what we have. Rule 1. Write the name of the metal first. Rule 2. Change the ending of the non-metal to "-ide". Okay? So, I have here name the, well, first of all, just to talk, this is not in your notes, but just for us to think about, in a compound made of the following pairs of elements, which one would I say first, iodine or copper? Copper. the full name would be copper iodide. If I was combining zinc and oxygen, which one would I say first? Zinc oxide. Sorry. What about fluorine and magnesium? Magnesium fluoride. And by the way, that's why it's called fluoride in your toothpaste, because it's bonded with something in your toothpaste. Okay. What will the ending of the following elements become? Fluorine would become what? Fluoride. Oxygen would become oxide. Nitrogen would become nitride, not nitrogide. Nitride. And you'll pick up on the ones that are a little bit different because we'll just be using them. So, on your homework right there, it says name the following compound. I'll do it up here. What would you call AgCl? What's Ag? This is going to be, careful, not argon. By the way, how do I know it couldn't be argon? Because argon can't bond with anything because it has a full valence shell. What is Ag?
Silver.
This is silver chloride. Let me see if I can move that up a little bit. Right there. Silver chloride. Okay? Try doing the next 5 on your own really, really quickly. I'll do them up here. Let's see if we get the same thing. Zinc oxide, calcium chloride, magnesium fluoride, aluminum sulfide, barium iodide. 1 sec is not an element. That's the IDE rule. That's the IDE rule. Now that's for ionic. The rules are different for naming covalent, but Lindsay knows you'll do those in Science 10. Aiden, you had a question or not?
No.
Okay.
I was thinking iodide, it's the same ion.
Yeah. They're a little weird. Okay. By the way, you'll notice, Kevin, in the name, I don't know that the name doesn't tell me that there's supposed to be a 2 on the iodine. The name doesn't tell me that there's supposed to be a 2 on the aluminum and a 3 on the, that's going to be the part of the formula, Nicole, that we're going to have to figure out. Ion charge. So, this is not in your notes, just to talk about. We have learned that ions, Amelia, can gain or lose electrons. We can figure that out from the periodic table. We said non-metals want to gain. You with me? Attention span here. Metals want to lose, and this is represented by the ion charge in the top right of each square of the periodic table, which again is why the noble gases all have no ion charge, because they don't form ions. So, do number 2 and 3 on the worksheet, remembering to change the endings after the non-metals to "ide." Okay, let's see here. So here's what I gave you. Symbol aluminum, symbol Al, ion charge. So I've given you barium, cesium, magnesium, potassium, silver, sodium, zinc. Fill that in really, really quickly. And you know what? Let's try doing both. And then we're going to combine aluminum and bromine to give you the combined name, combined name bromide, chlorine, chloride. Does that make sense? You can look at the examples. Take 30 seconds or so to fill this in. I'll do it here myself. I'm going to freeze the screen. I'll pause the video. So you should have, I think something like that, 2 and 3 filled in. Is that right? I got barium, B8, 2+. Well, you know what? I'm going to assume you got the symbols right. Reading across, I got 2 plus 2 plus 2 plus 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 plus. By the way, when it just says plus, what number are we talking about? Plus what? 1, we're that lazy, we don't bother. You can write the 1, I won't take marks off, but we're that lazy, Lexi, we don't bother writing the 1. Yeah? There's 2 of them cut off at the end? Oh, on mine? So, nitrogen and phosphorus. Nitrogen would be N. It'd be nitride. And I'm going from memory, nitrogen, 3 minus, is it? And I think phosphorus is 3 minus as well, yeah? Because they're right above each other. They're in the same, they're in the same family. Which one of the reasons they are in the same family is they have the same valence charge if they become an ion, same ion charge. Phosphorus is P or pH? Just P, and it'd be phosphide, not phosphoride. Thank you. Sorry, I didn't realize that it had got chopped off. Was I clever? Did I put it on the next page? No, I didn't. Okay. We'll come back. So, some patterns to notice. And again, you'll also notice, Kevin, in the middle of the periodic table, it gets all weird because everything that I've taught you is wrong. But certainly the ion charge that forms on all of the alkali metals, family 1, is what? Just plus 1. That's why they're all the alkali metals. And we've talked about why that means they react so fast as well, because they only got to get rid of 1 electron. They're very reactive. What's the ion charge that forms on all the alkali earth metals? Second column, second family. 2 plus. What about the ion charge that forms on all the elements in column number 16? What about the ion charge that forms on all the halogens? Minus.
And what about the noble gases?
Okay. So what have we learned so far? Before you turn the page, given the formula, we can name it, and we can get, element, the order matters, metal first, non-metal, change the non-metal to ide. We've learned how to find the ion charge. Now we're going to see if we can get the formula from the name, and this is where, sorry, it gets tougher. So, rule 3. When ions combine to form compounds, they're going to combine so that the ion charges are always balanced, or, by the way, instead of writing the word equal and the word 2 and the words, you could just go, right, equal 0. Equal to 0. Atoms want to combine in compounds that have no charge. If you're creating ionic compounds, all your pluses and all your minuses better cancel out. So, ion charge is the charge that forms on an atom when it gains or loses electrons. And remember, the ion charge can be found on your periodic table. Where? Now you can write that, or you can just say, right there, you draw a little square box and say, right there. By the way, do you see what's weird about the ones near the middle of your periodic table? What do you notice about some of their ion charges? They have more than one. They're called multivalent, and they're trickier. We're going to get to those maybe today. When an atom loses electrons, the ion will have negative or positive. If you lose negatives, what are you? Right? A positive charge. You can write the word positive, or do we have a handy symbol for positive? Yeah, plus sign. When an atom gains electrons, it will have a negative charge. Again, the joke I've told you probably 4 or 5 times. An atom walks into a bar and says to the bartender, I've lost an electron. The bartender says, are you sure? The atom says, yes, I'm positive. Right? That's the joke. That's the punchline. Okay. So, determining the formula. The chemical formula tells us which atoms, that's what goes in the first blank, in that little box that's kind of shaded in and looks kind of grungy. Sorry, it looked better in color when I hit print. Which atoms are present in a compound, and How many? That's what goes in the next blank. Of each, there are. And then ions combine in set ways to form compounds. That's the third blank. This is not in your notes. This is just to help you kind of think. If you had to determine the formula of sodium iodide, what would you write? Well, here's what you would say. Somewhere off in the margin, you would write, okay, here's sodium. Sodium is going to become an ion. What's sodium's charge? Plus. Here's iodide, iodine, but it's going to become an atom and combine, so we're going to call it iodide. Kyle? Minus. Do those cancel each other out? A plus and a minus? Then I only need one of each. Here would be the formula. The formula would be NaI. Really, it's Na1I1, but you've been in math long enough to know, Kiana, if I'm just writing ones, do I bother writing them anymore, or we just kind of say, right? Okay? So I'm going to erase the one. Is that okay? Can I erase the ones? Be lazy? We only put the numbers there if it doesn't work out to 1. What about calcium iodide? Okay, somewhere off in the margin, I would write calcium. What's calcium's charge? I would write iodide. For this to work, I'm going to need more than one of something. And how many? I'm going to need one more for iodide, for a total of 1 calcium, 2 iodides. How do you know that there needs to be a 2? Look at the charges. Look at the charges. That's the formula for calcium iodide. So, determining the formula, here's what I wrote. Since the overall atom up grand total charge on an individual molecule of a compound has to be 0, you can write out the word 0, or you can just write the number 0. Here's the key idea. The positive charges must balance the negative charges. Mitra, this is what we're going to be spending a few days working on. The positive charges must balance the negative charges. So, if a metal has a charge of 2+, then it can form a compound with either one metal ion with a charge of -2, where I wrote in the blank, the math there is +2 plus -2, 0. 1 times +2 plus 1 times -2, 1 of each. So what could calcium combine with very, very easily? Looking on your periodic table, what could calcium combine with in a nice 1-to-1 relationship? What's the charge on calcium? Don't write this down. 2+. Can you find me an ion that has a 2- charge? Which one? Okay, so calcium oxide forms very, very easily. What about right below it? Calcium sulfide. Calcium, what's right below sulfide? Calcium selenide, case. All of these would form in a nice 1-to-1 relationship because you've got 2+ and 2-. Or, if you have 2+, calcium can also form with 2 nonmetal ions of -1. The math there is 1 times +2 plus 2 times -1. As an example, calcium 2 iodines, or calcium 2 fluorides, or calcium 2 chlorides, or calcium 2 bromides, or calcium 2, what's the one, what is it? Astonides. I'm Usually you don't go that far down the periodic table. Is that okay, Lyndon? So it's math. I can't call it simple math, but it's math. There are mathematical rules that explain, Lena, why chemicals bond in certain ratios. It may help to think as if ions have the same number of hooks as the size of their charge. So for example, an F-negative ion has one hook. It wants to hook up with one electron. And a calcium-2 ion has two positive hooks. And the number of positive hooks and the number of negative hooks all have to get hooked together. These are something called hook diagrams. So as a picture, KBr. Potassium has a charge of plus. Bromide has a charge of minus. One hook each. You know what? That would be the actual formula. K1, don't write the 1. Br1, don't write the 1. Calcium. So if I was imagining calcium 2 plus, I would say it has two hooks. If I was imagining oxygen 2 minus, I would say that it has two hooks. Is every hook hooked up with another hook? And I know it's a lot of the words hook in one sentence, casual, but we all pair it up. We need one of each. Calcium oxide. What about calcium chloride? You can kind of Hudson... Oh, you guys are writing that diagram down? Okay. CaCl2. Why does it have to be CaCl2? Well, I imagine here is Ca, which is 2 plus, which means, Dan, it has two hooks. Here is Cl, which is minus. It has one hook. What's the problem? I still have one hook unpaired. I need another Cl to hook up with that one. Those, Mateo, are called hook diagrams. I won't ask you to draw hook diagrams, but I found some of my students, especially kids that are really into drawing and pictures, find this visual method better. I'm a math nerd. I find the mathematical methods better, Pierce, but I know some of my kids every year, oh, in pictures. Okay. I'm not going to do, well, okay, Na2O. Let's see. Here's Na, charge of +1. It has one hook. Here's oxygen, charge of 2 minus. It has two hooks. What's wrong with this picture? I need another to hook there. I need two sodiums for every oxygen. They're quick to draw, but says finish number 4 on the worksheet. We're just going to actually go to this tough one here. Okay? Rihanna, leave that one and do the tough one. I don't want you guys falling behind because I moved ahead. Let's do the tough one together, kiddo. Okay? The tough one. Why is this one tough? Well, if you just drew an aluminum, just let me walk through it and you can copy it out. What's the charge on aluminum? Now that would mean that it has 1, 2, 3 hooks. If I just draw an oxygen, charge 2 minus, that would mean that it has 1, 2 hooks. Can you see, Taya? I still have one aluminum hook dangling, so you might say, better draw another oxygen. Fair enough. I would go like this. Here's another oxygen. How many hooks does it have? 1, 2. Oh, now I've got an oxygen hook dangling. So, now what? Better draw another aluminum. Here's another aluminum with 1, 2, 3 hooks. Kyle, can you see now aluminum's not happy? It's got 2 hooks still dangling. What's the solution? Hey, draw another oxygen with 2 hooks. Lyndon, have I got everything hooked up, paired up? Then you know what? It's going to be 2 aluminum, Al2O3. There's a quicker way to get there, but as a visual way, Kevin, hopefully that kind of helps you imagine what's going on. The quicker way, another way, we got this copied down. Sorry, some of you still writing. Let me, I think I can go like this. Can I get it all on one screen? Not quite. Make it a little smaller, Mr. Dueck. No, a little smaller yet. Is that better, Farine? You can kind of see?
Yeah, I messed up.
You messed up? You know what? Do it in the square next to it and just draw an arrow. Okay. And again, let me be clear. I am not, Aiden, going to ask you to draw these on a test. You might find them helpful. Hopefully, most of you will actually embrace the shortcut. But this explains why the shortcut works. And I'm about to give you the shortcut. Hey, let's get to the shortcut. Formula activity, we're going to come to that in a second, I think. Another way to think of this, which is easier, but also a little easier to make a mistake, is called the crisscross rule. What you do is you write the ions with their charges. So if you want to combine aluminum and oxygen, you write Al, and up above it, as a little exponent, sort of, you write the 3+, and then you write O, and up above it, as a little exponent, you write the 2-. Then to actually figure out the formula, we move the number, not the plus minus, from the top to the subscript of the other one. Say what? We go like this, criss-cross. The formula is going to be Al2O3. Then repeat with the other ion. So remove the number, but don't put a positive or negative. From the charge of one ion to the subscript, remember subscript is a small number written below and to the right. Remember, you don't need to write a 1. It's not wrong, but you don't need to. So, remember, because we're using numbers to mean more than one thing, Rihanna, the location is very important. The subscript, the lower number, is the number of atoms. The superscript, the upper number, that's the ion charge. Sorry, if you put them in the wrong place, they're wrong. I won't give you part marks. They mean something totally different. So you ready? Let's try some of this. This is the crisscross shortcut. Let's try a couple. How would calcium, which has a charge of 2+, combine with chloride, which has a charge of 2-? Again, if you missed something, I'll come back. Let's get to this. So if you asked me to combine calcium and chloride, I would write out calcium, put its ion charge. I would write chloride, put its ion charge. And then, Nicole, the trick, the rule, the shortcut is to do that. The formula is going to be calcium. What's the number that's going to be underneath? What's the subscript of calcium? How many calciums are there going to be in this particular compound? Amelia, 1. What's the subscript, Aiden, that's going to be underneath the chloride? 2. That's the short way, that's the mathematical consequence, Jordan, of those hook diagrams. Lena's typing it into her phone? I hope not. You really can put it face down and away, kiddo. What if I want to write aluminum oxide? I would write aluminum 3 plus. I would write oxide 2 minus. I would then crisscross. It's going to be Al2O3. Is that okay? If I want to combine sodium and fluoride, I would go Na plus F negative. When I crisscross, oh, how many of each will there be here? One each. Will I write the ones? Nope. NAF. Forwards, it stands for not a factor, which is an expression sometimes people use. That person's a NAF, not a factor. I said it was easy to make a mistake. Here's the first tricky part, Riley, this next one. Calcium, 2 plus. Oxygen, 2 plus. When I crisscross, what would I have beneath each? Wrong. The rule is crisscross and then reduce to lowest terms. So instead of writing Ca2O2, it's going to be CaO. That's the second part of the crisscross rule. And I think I have this written here. You have to reduce to the lowest whole numbers, reduce to lowest terms. That's the part with the crisscross rule, Tristan, the shortcut that kids sometimes forget. In other words, if I was combining something, I'm going to make up some elements. We're going to have an element J for Jordan. We're going to have an element Ln for Lena. Let's suppose it was 6 and 3, and I crisscrossed. So 6 plus, Jordan is 6 positives, and of course Lena is nothing but negative. When I crisscrossed, I wouldn't write J3 Ln6. What would I write in lowest terms? So imagine the 3 there, imagine the 6 there, and then reduce. J1, am I going to write the 1? No. Ln3. Yep.
So
If it has the same charge.
like Ca2 plus 0, 2 minus?
Well, there it's when you, for the crisscross, what we're saying is you only need one of each. That's with my hook diagram. To make that work for the crisscross rule, it's going to be, look, if you happen to notice there's a lowest terms reducing factor that you can pull out, reduce it, please. Okay? So really, we're going to call it the crisscross rule, but what you should always hear, Mateo, the rule crisscross and reduce, but I'm just going to call it the crisscross shortcut, the crisscross trick. It says do number 5 and 6 on the worksheet. So I think here, ready? You guys have this, you got 6, hang on. Okay, there's the second part. Am I missing the first part, or do I have it in a different order? Okay, so let's try doing number 6, part 1, together right here. So I'm going to go like this. Well, hang on, let's go like this. Lithium and oxygen. Lithium is what? A positive metal ion? I know. Li plus. Fluoride is a negative metal, a non-ion. Okay, let's try doing some. What's the first one that you guys don't have filled in? Okay. So, sodium is what as an ion? Na is wrong. As an ion. I want the charge. Na plus. That's what's going to go in the first square. Nitrogen is what as an ion? Three minus. What will the formula be? Now, until you get good, I encourage you, with your pencil, go like that. Draw those in. You can even put arrows on the end. Now, probably by the time you get to grade 10 or 11, you'll do the crisscross in your head, and that's great. But until you get good, because now hopefully you can see it's going to be NA. What's going to be beneath the NA? N. What's beneath the N technically? 1. Am I going to write it? No. What would I call this? Uh-huh. What would I call this? Sodium what? Nitride. How many atoms grand total are there in this formula? How many sodiums? Not 1. Look, how many sodiums? 3. How many nitrogens? 1. How many atoms grand total?
4.
Okay? Try filling in the next 2 on your own. I'll do them up here. Oh, careful, don't write chlorine first because it's the nonmetal, even though I wrote it first in the chart. What are you going to write first?
MgCl.
Magnesium has a charge of Getting the hang of this, kiddo? It's tricky. On the last one, you have to reduce, right? Let me pause the video for a sec. So listen up, please. For your homework, I'd like you to try, if you turn the page in your notes, see if you can fill in, or so for you guys it's not turning the page actually, for you it's you have this chart. See if you can do this whole chart for homework. And then you can also do from section 3.2 homework, you can do the first page and only the first page. Now, remember I said in the middle of the periodic table, what did you notice about some of those particular ion charges? They're multivalent. That's going to be part 2, Thursday. We'll also talk about how we can use those polyatomic ions. It's going to get trickier, but I think you guys are getting the hang of the fundamentals. Everything's going to build on that. So for homework, front page of this, and finish off. Oop, scrolled up for some reason. Finish off question 6 from your notes. I'll go over the answers to that at the beginning of class. Also, if where was I, Mr. Dueck? Come on. We got right to here. So, and also, I will go over the answers to ionic and covalent bond. This one here. Okay.